Hey guys, just glance to this problem statement on graph traversals. So let's read out the problem statement. Baby names. Each year, the government releases a list of the 10,000 most common baby names and their frequencies, the number of the babies with the names. The only problem with this is that some names have multiple spellings. For example, JOH and John and JO and John are essentially the same name but would be listed separately in the list. Given to list one of names or frequencies and the other of pairs of equivalent names, we have to write an algorithm to print a new list of the true frequencies of each names. Note that if John, JOH and John and JO and John are synonyms, synonyms mean similar word of same meaning, and John, JO and John and Johnny, JOH and Y Johnny are synonyms, then JOH and John and Johnny are also synonyms. It is both transitive and symmetric. So by transitive, we have read about the transitive functions and the symmetric functions in sets theory. Set theory, okay, that is if A is related to B, then B is also related to C, then we can say that A is related to C. Similarly, symmetric state that if A is related to B and B is related to also A, then it is known as symmetric relation. So this might be satisfied in this case. And in the final list, any name can be used as the real name. Okay, so it states that government releases 10,000 of names of the newborn babies which contain the identical name of same meaning but with different spell. For example, it states that John, JOH and John and JO and John. So we're gonna use the concept of graph traversals. So we're gonna apply the DFS, depth first search. Why we're gonna use the depth first search? That might be our question, because depth first search, in this we're gonna represent the name as the nodes and the age, that is age of the graph, we can relate to the synonyms, that is the real synonyms of that, how many numbers are there. So the input we're gonna give that name John, JH and John 15, means there are 15 each identical name with spelling John, and JO and John there are 12 identical same names. So we're gonna categorize this in the similar part. Okay, so let's move to our code editor without much delay. We're gonna implement it on our code editor. So let's create a new Python file and named it as babyname.py. Okay, so at first we're gonna take the input as names in the variable in form of dictionary, that is name will be key and its counting will be value. That's for the first key will be John, JOH and John, as per the given in the question. Okay, its value is 15. Next key is John, JO and John, and its value is 12. Our third key is Chris, and its corresponding value is 13. Fourth one is Chris, and its value is 4. And the fifth is Christopher, Christopher, and its value is 19. Fine. So our first input is created. Next we're gonna take another variable as synonyms, SYNONYMS, synonyms equals to. Similarly, we're gonna store it in a dictionary format in key value pairs, which we will only include the matching pair. We will only include the similar pair, not the value. We will only include the key pair. Okay, that is mapped pair, that is key is related to one key is related to another key, as given in the question. We have to find that only, and the total number of counting, that is our only work. We have to make that an algorithm out of it. So first we're gonna use it in a tuple format, that is John, J and John, and we're gonna group it in the similar J, O, H and John. Next group is JOH and John and JONNY Johnny. Fine. Here we okay, fine. JOH and John, JO, here it will be H. Fine. Next, our third grouping is Chris, 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 and Chris, KRIS, Chris. Our fourth grouping is Chris, 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 and Christopher, Chris and Christopher. Done. So this is our two inputs which we need to take from the users. Okay, the name and the synonyms. Now we're gonna implement the DFS concept, depth first search. We're gonna represent the nodes of the graph as names and the synonyms as its ages. So how are we gonna do it? Let's move ahead. So first let's create a function. Okay, name it as baby names. We're gonna pass the and synonyms. Fine. Now we're gonna build our graph, that the nodes and the edges, we're gonna build that. Okay, so that we can create or plot the graph. So we take a variable graph and we're gonna use a library function default dict under we're gonna pass. So what actually default dict, let first import this library. So from collections import default dict. So what this default dict function actually do, this library function actually automatically creates an empty list for every new keys. Whenever a new keys is encountered, it will automatically creates an empty list so that we can represent it in a graphing node format. Okay, and we will connect it on the basis of the edges to the another nodes. So under this we're gonna pass the default argument, that is list. Next we're gonna create the edges of our graph. For that we use the for loop. For a is another edge, that is, as it is given in the question that our graph will be bidirectional, so we're gonna similarly represent it in our edges format. Okay, in bidirectional format. So the edges will be whenever I just began, I told that the synonyms will be represented as the edges of the graph and the names as the nodes of the graph. So similarly these edges will be represented as synonyms. Okay, under the synonyms, and it will be bidirectional, so the direction will be graph of a will be directed towards, we're gonna use the append function. Fine, so that we can represent the direction. Graph a will be directed to b, that is, sorry, the edge a will be directed to edge b from node 1 to node 2, and similarly symmetric function, no, so a is related to b and b is also related to a. Similarly we're gonna represent it as graph b is also related to a, that is, we're gonna append the a, so it follows the symmetric function. Okay, as a is related to b and b is related to a, so it satisfies symmetric functions as a relates b and b relates a. Fine. Next work is to represent the visited vertex. We're gonna represent it as visited. I take a variable that is visited, visited. We create it as empty set. Okay, so that we can store the visited vertex in an empty set. Next we're gonna store a result in an empty dictionary. We're gonna store this result in an empty dictionary. So now we how far we have done, we have taken the input name and synonyms from the users. Next we have created a function named it as baby names, where we have passed the parameter names and synonyms. Next we have created the graph and we use the default dict function from it is a type of library function which automatically creates an empty list from a new keys. Next we have represented our edges, that is, our edge must be bidirectional as stated in the question, that is, it will follow the symmetric function, so a is related to b, and similarly inversely b is also related to a. We have append that. Now we're gonna store the visited, we're gonna make a track of that whether a node is visited or not, so we're gonna use an empty set and we're gonna return the result in an empty dictionary. Now it's time to implement the DFS part. Okay, for that we create a function DFS and pass the name. Okay, now we're gonna track the visited node, whether a node is visited. So for that we're gonna do like visited dot add name. So what it will do, whenever a new node is encountered, so it will visit and it will append it in the set. So there is no append function in set, as you know that there is an add function in set to add something in the empty set. So whenever a new node will be visited, it will directly append that into a empty set. So next it will, let's create a variable which will return the numerical value, that how many node is visited. So for that we're gonna create a total variable which will return names dot get names. So what it actually does, and we will pass 0. Why we pass this, why we return this line? Can anyone explain that, what is the working of this line? For example, it adds a frequency. What I'm going to tell is that it adds a frequency. For example, if we take an example, that is, if name not in the names, it will generally return 0, like Johnny. If Johnny is not present here, as you can see that in names Johnny is not present, Johnny is present in the synonyms. Okay, so for that, in this case, it will, if there is no names found in this dictionary, then it will return 0. Fine. Next we're gonna explore the neighbor node. So for that we're gonna use a for neighbor for any I, let make it as a short form, in graph which will iterate the name. Okay, so the range will be name of graph of n. If the condition might be if neighbor not in visited node, then what it will do, it will increment total plus equals to DFS the neighbor node, DFS the neighbor. So let's write the working of this. So what this line does, this line act as a recursive function in the DFS. So it act as a recursive functions in DFS, and it's iterate DFS recursive recursive DFS recursive, which will add the total neighbor node whenever it visits. If the neighbor node is not present, it will iterate the DFS to the next. Okay, for example, if DFS John, under that DFS Jon John, and if DFS Johnny John Johnny, so the total number of the number means the value. So first John equals to, there is 15, next the value of John is 12, and the value of Johnny is, as Johnny is not present here in the name, so it will be 0, as stated earlier, it will be 0. So the total value will be 15 plus 12 plus 0 equals to 27. It will return the numerical value, the total value. So this will be under DFS recursive function. Okay, so now our next work is to traverse or name all the name. So next what we gonna do, we're gonna return this total. So we have to return this total, fine. Next we're gonna process each name. So for that another loop might be introduced for name in names. Remember that the name and names are two different variable. Okay, don't just confuse with it. So we're gonna give a condition if name not in visited node, then what we're gonna return, we're gonna return the result of name equals to DFS of name, fine. Now we're gonna return this result, so we're gonna return this result, fine. So our DFS concept, our main algorithm implementation concept is completed here. So now what we're gonna do, we're gonna call the function. For that we create a variable that is result, result equals to baby name, the first mother function, that is baby name. We're gonna call this and pass the parameter as names and synonyms. Next we're gonna iterate it in a for loop so that we can get a continuous value for each node for k and v, that is k, or let name it as a or b. Okay, in result of items, that is items is a dictionary, items it's a list value, it's a list. So what it will print, I'm using a format string format, that is f of a and the value, that is b. Let name it as name and val. Okay, so we can understand it easily, name and val. So our whole code is completed. So let's run this and check whether it is running or not. Okay, so it's giving a error. Let's troubleshoot it. Okay, so the error, yes, I found it out. As I told earlier that it is much confusing, so you need to just be careful on it. That is, it will be name, not names. Okay, so let's rerun it and check it whether it is coming the correct output or not. Bang, the output is displayed. So John is 27 and Chris is 36. So how are we gonna calculate it, whether it is coming correct or not? So let's cross check it whether it is coming correct or not. So here from the names, John is 15, okay, and John is 12. So 15 plus 12 equals to 27, and Johnny is another group, so it will not be considered in this similar group. So our total value of first pair is John, John and John, that is 15 plus 12 equals to 27. So our output is correct here. And second output is 36, Chris is 36. Okay, so why Chris is 36? Similarly, Chris is present in this CHRS, Chris is 13. Okay, 13 plus 4, that is Chris is also related to this also. And as it is transitive, A is related to B and B is related to C. As B is related to C, then A might be also related to C. So it's hold the similar concept. So for that, 13 plus 4 plus 19 equals to 36. So it has also given the right value. So that's how it works. So let's visualize this code, how it actually works.